Hey guys, let's get right into it. We got another exciting one here. This is concavity, so let's do this one. All right, first question here we have describe the concavity of the graph of this function and find the points of inflection, if any. It's an x cube, so it's definitely going to have a point of inflection. So we're going to take the derivative twice. So here we go. The first derivative, f prime, is 3x squared minus 5, and then we take another derivative, f prime prime, and we have 6x. So we have one point or one critical point. I don't really want to call it a critical point, but one candidate. I guess that's a better word. So I'm going to call this f prime prime. I put 0. If I have a negative number, negative x value, then the whole shebang is negative. If I have a positive number, then the whole thing is positive. So you can see changes from cavities because the sign changes. So there's definitely a change in concavity on F. So we look for that answer. Concave down from negative infinity to 0. Concave up from 0 to infinity. That's because the second derivative is positive. And point of inflection of 0, 4. So how did they get that 4, guys? Since we already said that x equals 0 is a point of inflection, plug in 0 in there. So 0 cubed minus 5 times 0 plus 4. So you get 0, 4 there. So this is the answer. All right, let's continue. Describe the concavity again. We're going to do the derivative. We're going to take the derivative twice. So f prime is equal to 4's canceled out, and you get 5x to the third minus 5x, and then we take another derivative, f prime prime. So we get 15x squared minus 5. If you want to factor out a 5, you can, and you get 3x squared minus 1. So from there, if we equal this to 0, we find our two candidates. And setting the 3x squared minus 1 equal to 0, 3x squared minus 1 equals 0, 3x squared equals 1, x squared equals 1/3, square root, and you get that x is equal to plus minus, I guess for now I'll write it like this, 1 over the square root of 3. When you rationalize it, multiply by the square root of 3 over the square root of 3, you get plus minus square root of 3 over 3. So right off the bat, we know that square root of 3 over 3, and those are possible candidates. So here we go. Negative square root of 3 over 3 and square root of 3 over 3. I call this f prime prime. I'm going to choose numbers to the left and to the right. I'm going to plug it into this guy right here, 15x squared minus 5. You can also plug it into this one. It doesn't really matter which one. So if I plug in negative 10 squared, I'm going to have a positive. Negative 10 squared is 100. 100 times 15 is 1500 minus 5 is a huge number. If I plug in a 0, I get a negative. And if I plug in a 10, I get a positive again. So I look for concave up between negative infinity and negative square root of 3 over 3 and square root of 3 and infinity, and here it is. Concave down between negative square root of 3 over 3 and square root of 3 over 3. Concave down, there it is. And then points of inflection. So the way they got these numbers, negative 25 over 36, is by plugging in square root of 3 over 3 in here. But since it's even, you know that you're going to be symmetric. You're going to get the same y value because it's an even function. So the answer is B. And there it is, guys. That's how we do that one. All right, guys. On this one here, hold on, let me just turn this off really quick. Now you're going to need a lot of space, so I'm going to start working over here. So I'm taking the derivative of this guy because, again, they want the same thing, describe the concavity. So I need to take the second derivative to see whether it's positive or negative. So before you even start, recognize that 16x squared minus 9. So you're going to have vertical asymptotes, and you cannot have points of inflection on a vertical asymptote. So I'm going to write 16x squared minus 9 here, and I'm going to solve for where 16x squared minus 9 is 0. So move the 9, so 16x squared equals 9. Divide by 16, so you have x squared equals 9 over 16. And then you take the square root, so you get x equals plus or minus 3 over 4. So now that you know that, those are vertical asymptotes, guys, at 3/4 and negative 3/4. So anything that says points of inflection at 3/4 and negative 3/4 is out. So point of inflection at 3/4, out. Let's see, on this one, it says points of inflection at 3/4 and 3/4, out. So those two are out, so now it's between A, C, and D. More than likely, it's not going to be D, but just in case. So let's go ahead and take this derivative, and let's see what's up. So I see this blank space here. I'm going to go ahead and write my first derivative there. So f prime of x. So bottom, 16x squared minus 9 times root of the top, 2 minus top, 2x times root of the bottom. 16 times 2 is 32, so 32x all over bottom squared. So 16x squared minus 9 squared. So I'm going to go ahead and distribute this 2 like so and see what's up. So let's see, 16x squared times 2, that's a 32x squared minus 18 minus 64x squared. All that is still over the bottom squared. So now my first derivative, yeah, if you have extra paper, guys, you might need it. You might not be able to fit everything in here in this thing. So negative 32x squared minus 18 all over the bottom squared. 16x squared minus 9 squared. All right, here we go. I'm going to do derivative again. So yes, I realize it's a little cumbersome, but you need to take the second derivative, guys, to know whether it's positive or negative. So here we go. F prime prime of x, and I'm going to go slow, bottom. So 16x squared minus 9 squared times the derivative of the top. And I see the negative 32x squared, so that's just going to be negative 64x minus top. So negative 32x squared minus 18 times the derivative of the bottom. So when we're doing derivative of the bottom, you're going to do chain rule. 2, leave the inside alone, 16x squared minus 9, close it, times 16x squared, that's 32x. Close, and then all that over bottom squared. So 16x squared minus 9 to the 4th. Okay, so let's see what we got here. I see that I can factor out. I see a 16x squared minus 9. I see a 16x squared minus 9. I see that I can probably factor out as well. Yeah, it looks like I can factor out 2 times 32 is 64. So I see a 64x there, and I see another 64x right here. So here it is. I'm going to write f prime prime, and I'm going to see if I can color code it, guys, to make this simple for you guys. So everything in blue I'm factoring out. So I see that I can factor out 1 of the 16x squared minus 9 and a 64x. So if I do that, let's see what I have left. I factor out a 16x squared minus 9, so I still have 1 left, and I have a negative there. So I have negative 16x squared plus 9. So let's see. I already factored out, let me write it in green. I factored out this guy, and then 2 times 64x, I factored out those two, and all I have left is this right here. So I'm going to have plus 32x squared plus, I see that as 18. I don't see that I made any mistakes. So far it looks okay. All that over the 16x squared minus 9 to the 4th. So I'm going to combine like terms here in the bottom, guys. So let's see what I finally have. So f prime prime of x. So here's my numerator. 16x squared minus 9, close, open. 64x, close, open. Negative 16x squared plus 32x squared, that's a 16x squared. And then 18 and 9, that's a 27. So I'm going to write plus 27. Let's see. Yeah, everything looks good so far. Equals that over the bottom squared, 16x squared minus 9 to the 4th. Okay, perfect. So I'm going to equal this to 0. So the only time that will be 0, okay, so what I'm circling in green, this will never be 0. Never 0. So the only time this will ever be 0, check it out, this one is when x is 0. So my critical numbers and my vertical asymptotes is what I'm going to plot in this line here. So here's my line, and I'm going to call that f prime prime. So here's my vertical asymptote, negative 3/4, and then I'm going to put 0, and then I put 3/4. There we go. So now all I care about is the second derivative, guys. I'm going to choose x values, and I'm going to exaggerate it, so I'm going to choose like negative 10. So if I plug in negative 10 in here, let's see, negative 10 squared is 100. 100 times 16 is a positive number, huge number, and then minus 9, so all this is still positive. 64 times negative 10, that's negative, so positive times a negative, and then this is always positive. So positive times a positive is a negative, so negative. And I'm plugging a number in between 0 and negative 3/4, like a negative 0.5. Let's see, 0.5 squared is 0.25 times 16. So that's going to be 4. 4 minus 9, that's a negative. So I see negative. And then 64 times a negative, I see another negative. Negative times a negative is a positive. So I see a positive right here, guys. Are we still okay? All right, continuing. I'm going to plug in a number like a half. Again, if I plug in a half, half squared is 1/4. 16 divided by 4 is 4. 4 minus 9 is a negative. So I see a negative, I see a positive, I see a positive, so that's negative. And then like a 10, I see positive, 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 so positive. And then I choose accordingly. These are vertical asymptotes, so they cannot be points of inflection. Vertical asymptote. All right, so concave down between negative infinity and negative 3/4 and 0 and 3/4. So let's see, nope, out. Negative infinity to 0, out for concave up. Concave down, negative infinity to 3/4, 0 to 3/4, perfect. Concave up between negative 3/4 and 0, yeah. 3/4 and infinity, yes. And point of inflection at 0, 0. Yep, 0 is a point of inflection. If you plug in 0 in here, you do get 0, 0. 0 divided by negative 9. So 0, 0 is a point of inflection, so the answer is A. Yes, guys, it is cumbersome, but you can do it. Invest the time. You're getting better with your algebra and your derivative rules anyway, so go for it. Keep going. All right, question 4 is back to simple. It doesn't look too extreme, so let's take a derivative. So we're going to do it twice. So I'm going to write f prime of x is equal to, so 4 times 5, that's 20. So 20 over 3, x plus 2 raised to the power. That's a 5/3. I'm going to subtract 1, so 3 over 3. 5/3 minus 3 over 3, I believe that's a 2/3. So I write 2/3. And then times 1 because of the derivative of the inside. And I'm going to take the derivative again. So I'm going to write f prime prime of x is equal to, so let's see, 20 times 2 is 40. So 40 over, then 3 times 3 is 9. X plus 2 to the power negative 1/3 times 1. So I'm going to rewrite this. F prime prime of x is equal to 40 over 9. And this is a cube root. That's a cube root of x plus 2. I'm going to look for candidates. My candidate is wherever this is either 0 or undefined. So I see one candidate at negative 2. So I'm going to write f prime prime, and I'm going to put negative 2 there. So if I choose a number to the left of negative 2, like negative 10, negative 10 plus 2 is a negative number, and I get positive divided by negative, so that will be negative. If I choose a number like 0, 0, so positive divided by positive is a positive, so I have a positive. So I do have a point of inflection at negative 2 because I do change signs. Now I know what you're saying, Chavez, you can't divide by 0. You're right, but this is not my original function. My original function is this guy, and you are defined. 0 is in the domain, or negative 2. Negative 2 is in the domain of this function. So even though negative 2 would make this f prime prime undefined, the definition of a point of inflection is where the second derivative changes signs, and if you're defined in the function, the original function. And it is, so we're good. So negative 2, concave down from negative infinity to negative 2, concave up from negative 2 to infinity. So there it is, concave down negative infinity to negative 2, concave up negative 2 to infinity, point of inflection negative 2, 0. If you plug in negative 2 in here, you get negative 2 plus 2, which is 0. And anytime 0 raised to anything is 0, except for 0 raised to the 0. That's something special. You'll find out about it in Cal 2, hopefully. Let's continue, guys. So there it is. Question 5 describes a concavity. I'm going to take the derivative, so I'm going to take the derivative twice again. So here we go. F prime of x is equal to 2x, and the derivative of sine 2x is going to be minus chain rule 2, oops, I was already going to make a mistake, cosine 2x. So there it is. I did chain rule, guys. I just put the 2 in the front because I knew I was going to take the derivative of the inside. Now I'm going to take the derivative again. F prime prime is equal to 2, and the derivative of cosine is a negative sign, so it's going to be a positive, so plus, and then 2 times 2 is 4, so 4 sine 2x. So now I'm going to set this equal to 0 to find possible candidates. Notice that your domain is between 0 and pi. That's pretty good. That's pretty good for us. So I'm going to write 4 sine 2x is equal to negative 2. Divide by 4, so you get sine 2x is equal to negative half. Arc sine, so 2x equals arc sine of negative half plus 2 pi n. All right, divide by 2. Well, I guess here's equation 1. Where is arc sine negative half? So the first one is going to be at 7 pi over 6. So 2x equals 7 pi over 6 plus 2 pi n. And then the second equation is going to be at 11 pi over 6. So 11 pi over 6 plus 2 pi n. So when you divide both suckers by 2, so look, there I am dividing by 2, divide by 2, divide by 2, divide by 2, divide by 2. So equation 1 comes out looking like this. X equals 7 pi over 12 plus pi n. This pi n won't be necessary, so 7 pi over 12 is one answer, or one candidate, sorry. And then another candidate is going to be 11 pi over, 11 pi over 12 plus pi n. That pi n goes away because if I add pi n, I'm already outside the domain. But 11 pi over 12 is inside the domain. So here we go, guys. Here's my number line. Notice that I put brackets because it ends at 0 and ends at pi. So 7 pi over 12 is just a little bit above half pi. So there's 7 pi over 12. And then 11 pi over 12 is really, really close to pi. So I'm going to say like right here. All right, I'm going to use a different color like blue. So if I choose a number like pi over 2, which is to the left of 7 pi over 12. So, and I'm plugging it in right here. So if I plug in pi over 2, I get 2 times pi over 2. The 2's cancel out and you get pi, and sine of pi is 0. So you just get 2, so that's positive. Are we still okay, guys? All right. So if I choose a number like 3 pi over 4, which is 75% of pi, which is somewhere in here, I get something like, let's see, 3 pi over 4 in here. 2 goes into 4 twice, so it's 3 pi over 2. Right here, sorry. So 2 times 3 pi over 4 turns to 3 pi over 2. I'm confusing you guys, I'm sorry. 2 times 3 pi over 4. Notice 2 goes into 4 twice, so that's 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times 4 is a negative 4. 2 plus a negative 4 is a negative number, so that's going to be negative like so. And if I choose a number bigger than 11 pi over 12, it's going to be positive, I can assure you. It's going to do a sign change like that. All right, cool. So let's see. Concave up between 0 and 7 pi over 12, yes. And 11 pi over 12 to pi, yes. Concave down between 7 pi over 12 and 11 pi over 12. There they are, guys. I'm surprised they didn't say points of inflection anywhere, but that's fine. Hope you liked that one, guys. All right, here we go. Next one. Find c of the graph cx squared minus x to the negative 2 at the point of inflection at 2, f of negative 2. So we're going to take the derivative twice, and we're going to force a sign change at 2. So here we go. F prime of x is equal to 2cx plus 2x to the negative 3. Take another derivative. 2c minus 6x to the negative 4. So I'm going to write 2c minus 6 over x to the 4th. And I'm going to force a sign change. So I'm going to force this to equal 0 when x is 2. So I'm going to plug in a 2 for x and 2 to the 4th. Let's see. So 2 to the 4th. Move this to the right. So 2c equals 6 over 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. 16. Divide by 2, divide by 2. Let's see. 2 goes into 6 3 times. So c must equal 3 over 16 for this to have a sign change. I hope that made sense, guys. If not, please rewind it and go through it again, please. So there it is. I forced f prime prime to have a sign change. So that's the only reason why I wrote 0, because you can't go from positive to negative or negative to positive without crossing the x-axis. So there it is. Let's keep going. The graphs are always simpler, guys. So it wants to know when the graph of f prime, let's see, this is the graph of, give the intervals of the graph of f of x is concave up. That's simple. F is concave up when f prime prime is positive. Now I don't have f prime prime, I have f prime. So let me write another statement. I'm going to write another statement. It's the same thing. F is concave up when f prime is increasing. And remember, you're not robots. That's exactly what this means. If f prime prime is positive, that literally means that f prime is increasing, guys. So where is f prime increasing? This is f prime, so I'm increasing on this interval. So from negative infinity to negative 2, and then I'm increasing again from 1 to infinity. So let's look for that. Negative infinity, negative 2, 1 to infinity. Awesome. Let's keep going, guys. Which of the following is true about the graph of this function? So notice it has a whole bunch of points of inflection, minimum, decreasing, increasing. So you're just going to have to take the derivative, the first one and the second one, and see what you get from there. So I'm going to write right here because I have a whole bunch of white space here, guys. So f prime of x is equal to the derivative of 6x cubed, 6 times 3, 6, 12, 18. So that's 18x squared minus 24x. Let me write this better. Plus 6. I'm going to equal this to 0. So let's see, what can I factor out? 6, I guess. So I don't think I made any mistakes. 6, 12, 18, yeah. 6 parentheses, so let's see, 6 goes into 18, 3. So 3x squared minus 6, 12. So that's 4x plus 1. And let's factor this guy out. 6 parentheses, 3x, close, open, x, close, 1, 1. And I needed to add up to a negative 4. So they're both negative. So they're making it kind of simple for me. So I get critical points at 1, and I get a critical point at 1/3. So here is my f prime. And I'm going to write 1/3 and 1. So if I plug in a 0, so let's see what happens. If I plug in a 0, I get negative times a negative, which is a positive. If I plug in a number bigger than 1/3, like a half, I get, let's say 3 times a half is 1.5 minus 1, which is positive. 1.5 minus 1, oh, sorry, 0.5 minus 1 is a negative. Positive times a negative is a negative. And if I plug a number like a 10, I get a positive again. So I'm going to look for something that makes this statement true. F of x has a point of inflection at 1, 7. Well, I don't know yet. Maybe. F has a local min at the point 1/3. No, it has a max. So that one's out. F is decreasing on the interval 1/3 to 1. That is a true statement. And as you can see, that's a correct answer there. F of x is increasing on 2/3 to infinity. Nope, that is a wrong statement because it's decreasing between 1/3 and 1, and 2/3 happens to fall within that interval. F of x has a local maximum at 1. No, I have a min. So I got lucky there, guys. I didn't have to do a second derivative because there's only one that's true there. You're not going to have two statements in here, A, B, C, or D, E, or E, that are going to be true. Only one, so there it is. All right, guys, here we go. This next question here, I'm going to have to take up a lot of this real estate. So here we go. Which of the following is true about the graph f of x equals blah, blah, on the interval 0 to pi? So again, I have points of inflection and increasing, decreasing, minimum, max. So let's take a first derivative. So I'm going to write up here since I got a lot of white space, guys. F prime of x equals, so the derivative, I'm going to have to chain roll, guys. 2 times 3 is 6. In case you're wondering what I'm doing, that's the same thing as 2 sine x to the third power. So 6 sine squared x, and then the derivative of sine x is cosine x. So, and then the derivative of 3 sine x is going to be plus 3 cosine x, and then the derivative of 1 is 0. So there it is. I think I did it right. Let's see. Let me just make sure, because not my second derivative is going to be wrong when I get to it. Everything checks out to me. I'm going to factor out a 3 cosine x, guys, and when I do that, I'm going to get, let's see, 2 sine squared x plus 1. So I'm going to get my candidates here. So I see that cosine x equals 0 when x is pi over 2 and 3 pi over 2, but 3 pi over 2 is not in that domain, 0 to pi. And then 2 sine squared x plus 1 will never be 0. That's always positive. So I'm going to do my number line, and I'm going to call this, oh, I can't put an arrow on it. I'm going to call this f prime, and the only critical number is pi over 2. So 0, pi, those are endpoints, and pi over 2. So if I choose, let's say, like pi over 4, cosine of pi over 4 square root of 2 over 2, so that's positive. If I choose 3 pi over 4, cosine of 3 pi over 4 is negative square root of 2 over 2, so that's a negative. So increasing, decreasing, so that's a max. So I look for that. Let's see, increasing pi over 2 to pi, that is wrong. I'm decreasing, out. And then local min at pi over 2, nope, that is a max. So that one is out. So now everything else has to do with the second derivative. So I'm going to take a second derivative, guys. So here we go. I'm going to take the second derivative from this guy. So I'm going to write it right here. F prime prime of x is equal to, let's see, I'm going to underline this and this, double underline. I'm going to be taking the product rule right there, guys. I'm going to leave that 6 on the outside. If you want to pair it with the sine squared, that's fine, but I like to leave it out. So first, so sine squared times the derivative of the second. The derivative of cosine is a negative sign, plus second cosine x times the derivative of the first, and the derivative of the first is going to be 2 sine x cosine x, chain rule. Stop with the bracket there, and then the derivative of cosine x is a negative, so minus 3 sine x. So again, I'm going to go ahead and distribute this. So I'm going to have f prime prime is equal to a negative 6 sine cubed x, let's see, plus 2 times 6 is 12, 12 sine x cosine squared x minus 3 sine x. So I see that all three terms have a sine x on them. So I'm going to factor out a sine x, guys. Now, because I want this first one to be positive, I'm going to factor out a negative. So I'm going to factor out a negative 3 sine x. So what I'm going to have is 2 sine squared x minus, let's see, 4 cosine squared x plus 1. I'm going to check that I didn't make any mistakes. I do not see any. I think I'm good at the moment. All right. So from here, you get that sine x is, I'm going to equal that to 0 to get candidates for concavity, points of inflection. Candidates for points of inflection, sorry guys. So sine x is going to be 0 at 0 and pi. Those are my endpoints. That does me no good. Now to solve this algebraically, I'm going to have to replace cosine squared. Now remember from your pre-cal days that cosine squared plus sine squared equals 1. So that means cosine squared x is equal to 1 minus sine squared x. So that's what I'm going to substitute, guys. So here we go. Negative 3 sine x, parenthesis, 2 sine squared x, minus 4, parenthesis, 1 minus sine squared x, close it, plus 1, equals 0. Distribute, distribute. So I have negative 3 sine x, 2 sine squared x, minus 4, plus sine squared x, plus 1. All that equals 0. Again, continuing, negative 3 sine x. Let's see, 2 sine squared plus 4. Sorry, you guys didn't tell me. Look, there's a 4 right there. How come you guys didn't tell me? Plus 4 sine squared. That's going to be 6 sine squared x. And then negative 4 plus 1 is going to be minus 3. All that equals 0. So finally, here we go. F prime prime. I know that I'm taking over question 10 here. Don't worry, guys. We'll be fine. Negative 3 sine x, open parenthesis. I guess I don't have to rewrite this, but I am, just so you guys can see what's up. Equals 0. So again, we already tested this guy, but this guy here we haven't. So I'm going to set this guy equal to 0. 6 sine squared x minus 3 equals 0. You don't have to show that step. You can just move the 3 immediately. 6 sine squared x equals 3. Divide by 6, divide by 6. So you get sine squared equals a half. Square root to get rid of that square there. Sine x equals 1 over square root of 2 plus minus. When you rationalize this, you get plus minus square root of 2 over 2. So on the unit circle, you're square root of 2 over 2 and all the 1s over 4. So power 4, 3 power 4, 5 power 4, 7 power 4. But because your domain is 0 to pi, you just care about the pi over 4 and the 3 power 4. So here we go. I'm going to do my number line. I'm going to call this pi. I'm going to call this 0. And we have pi over 4 the candidate and 3 pi over 4. All right. I'm going to choose a number smaller than pi over 4, like pi over 6. So let's see. If I plug in a pi over 6 in here, well, actually, let's see, no, let's just do it. It's pi over 6 in here. That is a half. Sine of pi over 6 is a half, and half squared is 1/4. So I get 6 over 4, which is equivalent to 3 over 2. So that's 3 over 2 minus 3. So that's going to be negative. And then sine of pi over 6 is a positive, but times a negative, so that's negative. Negative times a negative is a positive. If I plug in a number like pi over 2, sine of pi over 2 is 1, so you get 6 minus 3, which is positive. And then sine of pi over 2 is right here, that's another 1. So positive times a negative, I see a negative, and then that's going to be a positive as well. So there it is, guys. So concave up between 0 and pi over 4 and 3 pi over 4 and pi, so that's what I'm going to look for. So let's see. Concave, f has points of inflection. Okay, yeah. These are definitely points of inflection because the second derivative is changing signs. But I want to look at the other answer, see if we would have had right. If they're correct statements. Concave down to 0 to pi, that is false because you can see you're changing concave up, concave down. Concave up 0 to pi, that is also false. So the only one that's true is letter B. If you're wondering how they got the 2 squared to 2 minus 1, they plugged in pi over 4 and 3 pi over 4 into x. But yeah, so there it is, guys. So that's my answer. That's probably the hardest one in there, guys, because of all the substitutions that you got to do. But everything else goes back to easy. All right, so I'm going to do the last question here in blue. So that last question says, given the graph of f prime, so you have f prime, where is f of x decreasing? So this is f prime, guys. So f is decreasing when f prime is negative. So where is f prime negative? Right here and below the x-axis and right here. So let's see, that looks like these are little tick marks, 1, 2, 3, 4, 5. So it looks between -3 and 1, and then again 6, 7, 8, 8 to infinity. So -3 and 1 and 8 to infinity. All right, I hope you enjoyed this quiz, guys. It was pretty tough. I will agree, but I think you guys are tougher. So let's give it a shot and let's beat it up. All right, guys, see you guys later, and I hope you enjoyed this video. All right, bye.